trickier. So in this exercise, they've asked us to calculate the length of x in each diagram. So, and the good thing is they've told us, give your answers to 2 decimal places. So that means the answer we will get is probably not going to be, will have to be rounded somehow. So when I see something like this, the first thing you look at is, okay, I've got triangles. Are there right angles? Yes, because I've got this wee square here showing me the right angle triangles. Pythagoras comes to mind. I've been asked to find this distance x. I've got this distance 3 centimeter. What I need is to find this distance a, because once I've got a, then I know I can say that x square is just 3 square plus a square, according to Pythagoras' theorem. So how do I find a? I've got another triangle there, which is right angle. Hypotenuse 13, smallest square 5. This time a square is 13 square minus 5 square. So that means a is just square root of 13 square minus 5 square. And my answer for a, if you use your calculator, is 12 centimeter. So now I've got 3 centimeter, 12 centimeter. I can just use Pythagoras again to find x, but this time it's going to be 12 square plus 3 square, and taking the root of that, and I get 12.369 ... So I've not put the rest. But look at the question. Give your answer to how many decimal places?
2.
2, yeah. So that means, first of all, when I'm given a question like this, I'll write the answer with more than 2 and put the dots. So sometimes that could be giving me already a mark. And then I look at my third decimal place. Because it's 9, I need to round up. My 6 will go to 3, 7. Okay. So I've put here x is 12.37 to 2 decimal place. So someone might ask me, what if I put 12.37 centimeter? You will still get a mark, but to me, if someone put me x centimeter, the person is expecting me just to give my answer like this, 12.37, because a centimeter will come after I've plugged my x. Okay. Sometimes you will see a question where they just put x and they don't put the centimeter, and then you know that you've got to put the unit there, centimeter, 12.37. Because they've already told me, give me your answer in centimeter, then it's just 12.37. And the quick thing that I use to check, first of all, this 12.37 should be bigger than the 12 and the 3. Hypotenuse is always the longest of the 3 sides. And does it make sense? Yeah, kind of makes sense. It's more than 12. 3 is probably quite small. Okay. So that would be how you would answer this question. So you would do the same kind of calculation for the other 3 here. Again, using a 2-step attitude. For the first one, I would try and find b. So b is one of the shorter side. So it's going to be square root of 18 square minus 5 square, which is root of 299. And you've noticed I'll leave it as a square root because I know my next answer, x, is square root of 299 minus 12 square. So that's why I didn't need to write exactly what the distance for b was, or I didn't need to even round it. Yeah?
Yeah.
So I get 12.4498. Again, I'm going to have to round this to 12.45, 2 decimal places. And if you want to quickly check, you can use your calculator, and root 299 should be bigger than 12.45. Okay. So we looked at D. D was a bit more complicated because we had 11 plus x was square root of 15 square minus 9 square. So we had 11 plus x equal 12, and that meant x equal 1. Okay. For the next one, I'm looking at this and I've got a right angle here. First thing first, I'm going to try and find that long distance here because I've got hypotenuse and I've got a shorter side. So that means if I do calculation of A is square root of 30 square minus 23 square. And once I've got A, because I know I've got 11 here, I can figure out what distance this is going to be. So small a is root 371 minus 11, which is 8.26. And to find x, it's just square root of 8.26136 square plus 23 square. And square root of that is 24.438. 2 decimal place, 24.44. Okay, so the only difficulty here was to look at the right angle triangle here, is to figure out that I need to find this long distance because I've got this distance and this distance here. So in context again, I've been put 2 telegraph poles and been told that they are 2 meter high. They have wires, or straight wires, hopefully connected to the roof of a building. And the building itself is 9 meter high. How far apart are the 2 telegraph poles? So basically this distance here between the 2. So because I know Pythagoras, the first thing I'm going to do, I'm going to write down what I've been given. So 2 meter, 2 meter. This distance here, I'm going to call it, because this is 2 meter and this is 2 meter, and I've got a building which is 9 meter, the distance here is 7 meter. 9 take away 2, yeah?
Yep.
And now what I need to find is this distance here. So if I find A and if I find B, I just do A take away B, and I'm going to get the distance between the 2 poles. Yeah?
Mm-hmm.
So I've got a couple of right angle triangle, a big one there. So A is square root of 15 square minus 7 square. That's my A here. B is square root of 10 square minus 7 square. And if I do plug all this into your calculator, my answer here, x, becomes 6.125. Because we've been asked to give the answer with 2 decimal place, I just round it to 6.13. And it's in meter here. So the difficulty here was, first of all, identify the 2 right angle triangles. Find out these distances when you know you've got that distance, those distances, but how do you get that distance? You know, the height of the building and the height of the poles, and that's how you find that. That's probably the trickiest one to extract from what you've been given. Okay?
Mm-hmm.
So would that make sense? Yeah? If this is 7 meter, you can have 2 poles, you know, and both are 6.13 meter apart. That would make kind of sense. Okay. And these are the type of in-context calculation that you may be maybe face one day. You never know. You could be working on trying to put a suspension bridge, and some suspension bridges have got cables holding the bridge together, and they do use Pythagoras. And I think I was watching this program about the guy who's going into France and doing these chateaus. Don't know if you've watched any of these. Chateau or something in France, DIY chateaus. And the guy was making a chandelier. His wife asked him to put the chandelier together, and the first thing he said, "Oh, I'm going to have to use Pythagoras here to measure the distance between that point." And I went, "There you go." He remembered his math at school. I know it was a bit.
That's me. I'll give you a shout out.
I do remember Pythagoras, and I do like applying it. But you're right; it's putting it in context and
Yeah.
using it. I do remember it. I must admit, it wasn't my favourite thing, but I do remember how the crux of it. Like you don't forget these things.
So it's quite powerful. Quite powerful. It's been used.
After 10 years later, I would need it. 10, 12 years later.
And I think we had done this one.
Yeah.
When we had points. So let me find out. All right. So the last type of exercise, usually you might get asked during an exam for Nat 5, is use the converse of Pythagoras to determine if you've got a right angle triangle or not. So the converse just tells us for this to be right angle, first of all, I'll calculate hypotenuse square. That gives me 169. Then you calculate the two shorter sides square, and you add those values. And if those two numbers are the same, you can clearly say that this right angle triangle, this triangle is right angle. Yeah. So as 13 square equal 12 plus 5, there's a wee statement that is asked to the student to write by the converse of Pythagoras. So you just need to remember that, by the converse of Pythagoras. How can you remember that? You just think about those shoes that kids used to wear in the old days called Converse.
Still wear them.
Still wear them, yeah.
Still wear them.
Converse. We have a right angle triangle. Yeah, so that's the way we do this. So you've got quite a few here. Now, sometimes the difficulty is to find which of the three sides is the longest, so where your right angle might be. So the right angle will be where you've got 1.7 here. So you need to do 1.7 square on its own. Then you do the 1.5 square plus 0.8 square. And if those two numbers are the same, you can clearly say this is a right angle. Even if it doesn't look like a right angle, remember they don't give you these to scale. So it should have probably be a bit more here. Okay. So I'm just using a shorter version, right angle triangle. This one, 20 square is 400. 12 square plus 16 square, again 400. I've got a right angle here by the converse of Pythagoras. I think C, we looked at it. We got 49 and 34, so we knew straight away that wasn't a right angle. This one, I've got root 7. You need to square that. Remember, root 7 square, to get rid of a root, you square it. So we got rid of the root, and it's 7. Now we need to do the same for root 5. So root 5 square is going to be 5. Root 2 square is going to be 2. 5 plus 2 should give us the 7. So I expect this to be a right angle triangle. Okay. So there's no much calculation here apart from a 5 plus 2. But you just need to remember that root 5 square is 2. It's the opposite. And this question here, we had Fergus. He was putting up a shelf. James came in says it looks wrong. Now, he measured the dimension of the picture to decide if the shelf has been put up to square. So, to prove his brother's wrong, he's going to have to prove him that 23.8 square is the same as 18.5 square plus 15 square. So let's do the calculation. I've got 566.44. I've got 567.25. Look at how close they are. Because they're different,
No, not much.
the shelf is, I know, I would, to be honest, it would be so close that I would just say, look, to me, it's good enough, to be honest, but by one digit. But yeah, but to answer this question, you would say, because the two numbers are not exactly the same, then by the converse of Pythagoras, the shelf has not been put completely square to the wall. So I don't know how his brother managed to see it with his bare eye, but there you go. Again, if this was a proper exam question, they would make the 23.8 like a 25, for example. Then you would tell, okay, I can see a big difference between the two. Not something that close. Okay. So was that more? Oh yeah, the 3D. So 3D Pythagoras was the last thing we did. Okay, so what we came up with was the longest distance between those two endpoints would just be square root of 5 square plus 4 square plus 8 square. So you're okay to use that. Just say 3D Pythagoras. Calculate the space diagonal. So that's what they call the space diagonal. It's the diagonal, the longest length, longest straight length that you could put within a cuboid. So to find that, you just do square root of each of those side lengths square times breadth square times height square in this case. And I get 10.246. They've asked us to 2 decimal place 10.25 centimeter. Okay. And the question you might be asked is, within this box, could you fit, you know, a pencil which is 11 centimeter long, for example? And you would say no, because the longest that I can fit in is 10.25. Okay. Next is exactly the same. So I've got root of 6 square plus 7 square plus 10 square, which is 13.60. So again, they've asked me to put it to 2 decimal places. You've got to write the 2 decimal places. This is where people would lose a very silly mark because they only stop at 13.6 because they said, oh, 13.6 or 13.60 is the same. It is not exactly the same when you write to give an exact dimension. Because by giving it that way, you've given your answer with more significant figures. Okay, and significant figures is what they use to measure accuracy of a measurement. It's a bit like when they tell you, oh, in this stadium we had 25,000 spectator or fans that turned up. It's 2 significant figures because it could be 25,150 or it could be 24,980, for example. So they all put it into a 25,000 as a 2 significant figures. And I think this was the last one. Find Z, space diagonal, square root of 3 square plus 5 square plus 12 square. And that is 13.34 centimeter to 2 decimal place. So yeah, this is what the guy was doing. He was in this program, he was trying to put like a chandelier and he had something similar to this. And he had to measure the length of a metal rod that he had to solder between that dimension. So instead of the 25, he knew what that distance was. So in this example, we've been asked to find the height how high is the bend. So this is a bend, and give your answer to 3 significant figures. So first of all, this is what we've been asked to calculate. So how do I find this? I'm going to look into pulling some right angle triangles here. So if I'm given a diameter of 36, the radius is this distance here. It's going to be half that. Yeah? Half of 36, that would be 18. And the bottom of the bend, I've got a radius of 20 centimeter, or diameter of 20 centimeter, then the radius is just 10 centimeter. So I've got 2 radii, or a big radius at the top, 18, and a small one, 10. Then straight away, you can see the difference here between that radius and that radius would give me 8 centimeter, which is that distance. So I've got a right angle triangle. I've got one side, another side, 8 centimeter. So I can find this side. Question, is it a shorter side or a longer side? So it's a shorter one. That means I need to use square root of 25 square minus 8 square. And that would be the answer for that height. So I write the full answer there, 23.685. But we were asked to give the answer to 3 significant figures. So I'm looking at the 4th significant figures here, which is an 8. That means my 3rd figure needs to go up, like a round up. And that becomes 23.7 centimeter to 3 significant figures. And you would get all your marks. So you can see this was quite a tricky question, but it's got a star, so it's a question that you could get asked. First thing is to identify your right angle, to find that distance here, which is what you're looking for. You've been given a couple of distances. What can you do with them? I've got a circle here and a circle there. It doesn't look that circle-wise, but to me, again, if I was to give feedback on this question, I would ask whoever's writing that question, make sure that they know that these bottom and top bit as circles, because you could argue that that might not be a circle, but you can see that this distance is half of that distance. Yeah. So I think someone might argue back to me and tell me, yeah, but they can see that half of 20 is 10. Okay. And I think this one we did together.
Yeah.
With a 2.7 meter long, and we calculated 2.92, and who was correct? Yeah, you can fit a 2.7 meter. So if you were to move house one day and you've got a long pole to carry with you, you can do a quick calculation before you hire your van or whatever, and be able to figure out what you can put in. So I'm not going to go through that question there, because we'll do it when we look at vectors. Okay. This one will come into applications when we do vectors. Okay. And I think that's probably was it. Let me see. I've given the answer, but yeah. Okay. And I'm gonna